All right, in this video, we're going to take a look at rational inequalities. And you're probably going to notice that the process to solving these is going to be pretty similar to quadratic and cubic inequalities. I shouldn't say pretty similar, but we're going to make a sign chart again, just like we did with those. So let's look at this first one here. We have 3x minus 7 over 2x plus 1 is greater than 0. I'm going to start and I'm going to set the factors in the numerator and denominator equal to 0. This is going to give me the two numbers at which this inequality could change sign. All right, so when I solve this equation, I get x equals 7/3. And when I solve this equation, I get x equals negative 1/2. Now I'm going to plot these numbers on a number line. And I'm going to plot them in numerical order. Negative 1 over 2 is smaller than 7 over 3, so it needs to go on the left. Okay, and these are the only two numbers at which this inequality could possibly change sign. What I mean by that is change sign from positive to negative or negative to positive. And a sign chart is going to be helpful, once again, in determining the solution set to this rational inequality. So up here at the top, I'm going to write the three intervals that I see on my number line here. Excuse me. So my first interval is negative infinity to negative 1/2. My second interval is negative 1/2 to 7/3. And my third interval is 7/3 to infinity. Okay, now notice that I'm using parentheses because my inequality symbol is a greater than symbol, not greater than or equal to. So I'm going to use parentheses for this example. Down here, I'm going to write my two factors, the factor from the numerator and the factor from the denominator. And then just as we do with quadratic and cubic inequalities, we're going to pick a number to test in each of these intervals. And we're only interested in whether we get a positive result or a negative result. So I need to pick a number less than negative 1/2. How about negative 1? And then I need to pick a number in between here. How about 0? I mentioned 0 is always an easy number to test. And then a number greater than 7 over 3. 7/3 is 2 1/3. So how about 3? Again, we're only interested in positive or negative. So when I substitute negative 1 for x in the top factor here, I get a negative result. When I plug negative 1 for x into the second factor, I also get a negative result. A negative divided by a negative is a positive result. So notice I've got a quotient here. So negative divided by negative is a positive. I'll put a little smiley face here. This is going to be part of our solution set because we're interested in where this quotient is greater than 0. Greater than 0. So I got a positive result, and so therefore this interval, which I can go ahead and graph over here if I want, that interval of numbers will be part of our solution set. Now I only plugged in negative 1, but every number in this interval would give us the same results. We'd get a negative, and a negative divided by negative is a positive. Now I'm going to plug in 0. When I plug 0 into this first binomial here, I get a negative result. When I plug 0 into the bottom one, I get a positive result. And a negative divided by a positive is a negative. So this interval is not part of our solution set. And then finally, when I plug in a 3, I get a positive result. I get a positive result. A positive divided by a positive is positive. And so this interval is also part of our solution set. So it looks like our solution set is the interval from negative infinity to negative 1/2, including the interval from 7/3 to infinity. So here's our answer in interval notation. All right, so that's how we do a pretty basic rational inequality. Now let's look at, we're going to look at a couple more here, and they're going to be a little bit more difficult. So let's look at number 2. What makes number 2 difficult is I don't have a 0 on one side of the inequality. And if I'm going to find the numbers at which this inequality could change sign, I need a 0 on one side of the inequality. So what I'm going to do is I'm going to subtract 3 over x minus 2 from both sides. So here I'm subtracting it from the left-hand side. When I subtract it from the right-hand side, I end up getting 0. I'll just put my 0 over there. Okay, now let me just say, please, please, please do not try to cross multiply. We cannot cross multiply with an inequality, just with an equal sign or an equation. Okay, now I want to make this left-hand side of this inequality look like my last problem, where I just have, you know, let me go back up here, where I just have, you know, a binomial over a binomial, or at least, you know, a rational expression. I need a polynomial on top, one polynomial on bottom. And right now I've got 2 rational expressions that are being subtracted. I've got a difference of rational expressions. So what I'm going to do is I'm going to find a common denominator, and that common denominator is x plus 6 times the quantity x minus 2. So I'm going to multiply the first rational expression, both the numerator and denominator, by x minus 2. And I'm going to multiply the second rational expression, both numerator and denominator, by x plus 6. Now I have a common denominator, and so since I have a common denominator, I'm able to subtract numerators and retain that common denominator. I'm going to subtract my numerators, retain, that common denominator. Now the order in which I write the factors in the denominator does not matter. All right, now I'm going to distribute in the numerator, and then I will combine like terms. Okay, so my new problem becomes x minus 26 over x plus 6 times the quantity x minus 2 is less than 0. Okay, so now this looks a lot like the one before, except I guess we have a trinomial in the denominator here. If we would FOIL out those 2 factors, we get a trinomial. Okay, but I'm still going to set up a sign chart, and I'm still going to make a number line. I feel like that's helpful. Now the numbers that go on the number line are what we get from setting the numerator and the denominator equal to 0. These are the numbers at which our inequality could possibly change sign. So I have x equals 26, x equals negative 6, or 2. So here are my 3 numbers that I'm going to put on my number line. I'll go ahead and make my number line up here. I'm going to put these numbers in numerical order. Negative 6 is the smallest, followed by 2, followed by 26. And I can see that my number line is split into 4 different intervals this time. I've got negative infinity to negative 6, negative 6 to 2, 2 to 26, and 26 to infinity. So those intervals are going to go in my sign chart. All right, let's make a sign chart here. I guess I'll make my sign chart I think I'll make it small enough to make it down here. All right, so here we go. So we've got, here's our sign chart. And I've got 4 intervals, negative infinity to negative 6, negative 6 to 2, 2 to 26, and 26 to infinity. And I'm going to write my 3 factors here, x minus 6, a factor from the numerator. Then I'm going to write the 2 factors from the denominator. And we're going to pick a number in each interval to test. We're just going to be concerned with positive or negative. And we'll see what our result will be. Okay, so let's choose. We got to choose a number less than negative 6. How about negative 7? We have to choose a number between negative 6 and 2. How about 0? A number between 2 and 26. How about 3? And then a number bigger than 26. How about 27? When I plug negative 7 in to the first binomial, I get a negative result. Then I get a negative result. Then I get a negative result. 3 negatives will give me a negative result overall because, let's see, these factors are in the denominator. If you multiply a negative times a negative, you get a positive. So our denominator would be positive, but our numerator is negative. So a negative divided by a positive is negative. You could also just look at to see if you're going to have an odd number of negatives, it's going to end up being negative. If you have an even number of negatives, it's going to be positive. Okay, let's see. 0, negative result, positive result, negative result. This would end up being positive. I just mentioned if you have an even number of negatives, it's going to end up being positive. 3 would be negative, positive, positive, which would be negative. This would mean a numerator that's negative, but a denominator that's positive, and a negative divided by a positive is negative. And then 27 is positive, 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 which would be a positive result. Now in our problem here, we're looking for less than 0, less than 0. So this here is less than 0. Sorry, that's supposed to be a smiley face. This here is less than 0. So our solution set is going to include the intervals negative infinity to negative 6, as well as 2 to 26. I'm using parentheses because I'm interested in less than 0. So I will not use brackets on a problem like this. Okay, now if you want to see the graph would look like this. But again, you don't have to graph unless you feel like it helps. But we found that this interval of numbers is part of the solution set as well as this interval of numbers here. So that's what our graph would look like. Okay, one last rational inequality for this problem, or this video, I'm sorry. Again, if I'm going to use the same process, use my sign chart, I need a 0 over here. So the first thing I'm going to do is I'm going to subtract 3 from both sides of the inequality. Then I want to make it look like the last couple of problems. And so I'm going to need to combine these. I need to subtract 3, but I can't subtract 3 unless I have a common denominator. So I'm going to think of the 3 as kind of like 3 over 1, and I'll multiply both the numerator and the denominator by x plus 1. This is going to allow me to subtract that 3, and I'll be able to get just a single rational expression on the left-hand side. So I am now going to subtract numerators and retain that common denominator. And I will distribute make that, use that as my negative sign. So negative x minus 5 minus 3x minus 3. And this is all over x plus 1. And we'll combine like terms. Negative x minus 3x would be negative 4x. And negative 5 minus 3 is negative 8. And then that's over x plus 1. All right, so we've got it looking pretty good here. We've got a single rational expression. We've got a 0. And so we want to know, when is this quotient less than or equal to 0? So I'm going to set the factor in the numerator equal to 0, as well as the factor in the denominator. This is going to tell me the numbers at which this inequality could change signs. When I solve here, I get x equals negative 2. When I solve over here, I get x equals negative 1. I'm going to plot those numbers on my number line in numerical order. Negative 2 is smaller than negative 1, so it goes on the left. And then now I'm going to make a sign chart and enter my intervals. Sorry here, I'm going to scroll down just a little bit to make my sign chart. All right, so here's my sign chart. I've got 3 intervals. All right, now we need to be a little careful about our parentheses and brackets here. This symbol is a less than or equal to. So typically we use brackets for the interval notation when we have a less than or equal to. But I can't use a bracket or brackets near a negative 1 or by the negative 1. This is because I can't divide by 0. Division by 0 is undefined. So when I go to write my intervals, I've got the interval negative infinity to negative 2. I will use a bracket by the negative 2, and then negative 2 to negative 1, but I'm going to use a parenthesis by the negative 1 both times I write it. And so this all has to do with the fact that although this is a less than or equal to 0, we cannot divide by 0. So we do not want to put a bracket by the negative 1, which would imply that negative 1 is part of our solution set. Negative 1 is not part of our solution set. X plus 1 cannot equal 0 because division by 0 is undefined. So negative 1 is not part of our solution set. We have to make sure that whatever we get from setting the factor in the denominator equal to 0, we put a parenthesis right by that number no matter what the original inequality symbol is. Okay, so I'm going to write my factors now. And just as I've been doing before, I'm going to choose a number in each interval to test or to plug in. I need a number less than negative 2. How about negative 3? I need a number in between here. Ooh, this one's a little tough. How about negative 1.5? And then a number bigger than negative 1, how about 0? When I plug negative 3 into the first binomial, I get a positive result. When I plug negative 3 into the bottom binomial, I get a negative result. And a positive divided by a negative is negative. Now, since my inequality symbol is a less than or equal to 0, this means that this interval is part of our solution set. So all numbers in this interval will satisfy the inequality. Let's see, when I plug in negative 1.5, this is a negative result, and this is a negative result. And a negative divided by a negative is positive. So that interval is not part of our solution set. We're looking for this quotient to be less than or equal to 0. And then finally, 0 gives me a negative result and then a positive result. A negative divided by a positive is a negative, so this interval is also part of our solution set. Okay, but notice I'm putting a parenthesis, or parenthesis I think is like the singular, sorry, I should say parenthesis, here at the -1 because x cannot equal -1. We don't want to include -1 in our solution set because division by 0 is undefined. All right, so our final solution in interval notation, our solution set, would look like this. So be careful on these rational inequalities. Even if your symbol is a less than or equal to or greater than or equal to, we're going to use a parenthesis next to any number that comes from the denominator because division by 0 is undefined. All right, well, hope everyone enjoyed this video, and I hope you have a better understanding of rational inequalities.